In this lesson, we will cover Unit 3, Section 4.6, Applying the Exponent Laws. In this lesson, you will learn how to apply the exponent laws to expressions with rational and variable bases, and integral and rational exponents. Then you have to explain the reasoning behind these. First, let's review all the exponent laws that we have covered so far. The first, product of powers. When you have the same base being multiplied, you must add the exponents. 2, quotient of powers. When you divide the same base, you have to subtract your exponents. 3, power of a power. When you have a base of a being raised to an exponent and then raised to another exponent, those two exponents are multiplied. 4, power of a product. You have two integers, a and b, being multiplied and raised to an exponent. Both integers are then raised to the exact same exponent. 5, power of a quotient. Two integers, a and b, are divided and being raised to the exponent of m. The numerator a is raised to the exponent of m, and the denominator b is raised to the exact same exponent. It is important to note here that b, whatever the integer is, must not equal 0. Unlike grade 9, when you use the laws of exponents to simplify an expression, we will be involving multiple exponent laws in 1201. In order to do this, it is important to follow some guidelines. First, simplify the expression inside the bracket. Similar to BEDMAS, you will follow along with the brackets first. Have a look at the expression inside and see what you can simplify. You can do this by removing the brackets, by applying the exponent laws for products of powers, quotients of powers, or power of a power. Lastly, you will then write the simplest expression using positive exponents. From the previous section, we learned that we cannot have an answer with a negative exponent. If we do, we must take the reciprocal of the base, leave the exponent the same, and keep it positive. Using the laws of exponents, identifying and correcting the errors are very popular questions. Here we will have to decide what law to use, where the student went wrong in their solution, and fix their mistake. If we look at this question, we will realize that a and b are the same bases in both brackets. Since we have this, we can group a and a together. They have different exponents, but everything is being multiplied. We will use the exponent law, product of powers. When you have the same base and you multiply, you add. Similar again, b to the exponent of -1 and b to the exponent of -3. Those bases are being multiplied, therefore you have to add your exponents. So far, in step 1 after the question, there are no mistakes. All they did was group together their common bases and multiply. Next, in our answer, we must see where they made mistake. We know from the exponent law, when you multiply the same base, you have to add. 3 plus 1/4 does not equal 3/4. When you add a fraction and a whole number, you must get a common denominator. By doing this, we can say 3 divided by 1 plus 1/4. Multiply 3 divided by 1 by common denominator, which will be 12, so we'll multiply the numerator and denominator here by 4. This will give us 12 divided by 4 plus 1 divided by 4. As a result, a should have an exponent of 13 divided by 4. We can leave this alone because it already has a positive exponent. Next, b to the -1 and b to the -3. When we add that together, we will get -4. This is not what they have there. it will not be b to the exponent of 3. b to the negative 4 is a negative exponent. Therefore, we must take the reciprocal of the base, leaving the exponent the same. The final answer for this question will be a to the exponent of 13 divided by 4, all divided by b to the exponent of 4. In summary, we will now look at some of the big ideas that were covered in the last few sections that will be used in the laws of exponents. Any number that can be written as a fraction, where m and n are integers, is a rational number. If a number can be written as a fraction, or if the number is a terminating or repeating decimal, it is a rational number. If a number does not fall into one of these characteristics, it is irrational. Next, exponents can be used to represent roots and reciprocals of rational numbers. Keeping in mind that the numerator of a rational exponent indicates a power, while the denominator indicates a root. A negative exponent indicates a reciprocal. And lastly, the exponent laws can be extended to include powers with rational and variable bases, and rational exponents. We can use the exponent laws to simplify expressions that involve rational exponents.